Hello, everyone. Thank you for coming to CEIMIA's second of three webinars on AI interoperability. And by way of introduction, CEIMIA is a nonprofit organization based in Montreal, Canada, that mobilizes expertise and resources to promote the development and responsible use of AI for the benefit of humanity. This work is done through innovative, socially responsible, and high-impact applied AI projects, such as this one, conducted with the support of Google.org on AI regulatory and technical interoperability. First webinar detailed the current state of AI governance, some of its challenges and possible ways forward to address those challenges. One recurring solution or recurring challenge was the growing fragmentation and convolution of AI regulation and technical efforts within and across borders, which leads to increased compliance costs, creates barriers to entry for small and medium-sized firms, reinforces enforcement capacity, and can lead to regulatory and technical venue shopping, among several other challenges. Regulatory and technical interoperability, the intentional overlap and consistency between rules, or the connection between one or more systems, services, or platforms infrastructure, are one pathway that could address some of these challenges, among others. While AI regulatory and technical interoperability might logically follow to address these challenges, we don't really know how these sorts of regulatory or technical interoperability efforts have played out in other sectors. What are their geopolitical climates like during those efforts? What led to their successes or failures? And how and when were these interoperability interventions taken? During this webinar, you'll be hearing presentations from our four panelists that explore these and other questions on the successful or failed regulatory and technical interoperability efforts across four case studies. Following the presentations, we'll have a brief discussion around their presentations' overarching themes and a Q&A with you guys, the audience, to end things off. And this webinar is being recorded just for dissemination purposes. So, our four panelists. We have Graham Auld, who is the professor in Carleton's University School of Public Policy and Administration, where he co-leads the Decentered Governance in the Digital Era Project Lab. He has broad interests in comparative environmental politics and global environmental governance, with a particular focus on transnational private governance regimes. His recent work focuses on the role of private auditors in public and private regulatory processes, including in emerging AI governance. We have Laura DeNardis, who is the endowed chair in Tech, Ethics, and Society at Georgetown University, and a leading scholar of technology and society. She has written widely on internet governance, totaling 8 books and countless articles. Laura is also a life member of the Council on Foreign Relations and an affiliated fellow of the Yale Information Society Project, where she previously served as executive director. We have Gary Marchant, who is a Regents Professor and faculty director of the Center for Law, Science, and Innovation at ASU's Law School. Gary's research interests include the governance of emerging technologies like genomics, biotechnology, nanotechnology, AI, and neuroscience, among others. He has authored more than 200 articles, books, and book chapters on various issues relating to these and other emerging technologies. And finally, we have Cornelia, who is the managing director at Considerati's Brussels office and a board member of the IAPP's AI Governance Center and Center of Digital Constitutionalism and Policy. Prior to these roles, she led Microsoft's Responsible Tech and Competition team in Europe and led the European Consumer Organization's legal department. She has accumulated 15 plus years of experience in the tech policy space. During these presentations, please feel free to type your questions in the Q&A chat, and we'll answer as many as we can after the presentation and discussion. To start, we'll be hearing from Dr. Graham.
Super. Thank you so much, Benjamin. Really a pleasure to be here joining you. And I'm just going to share my slides now and then get started. Slides look okay? See them? Yes? Perfect. So it's a pleasure to kick off this session, the second of the webinar series. I'm just going to jump right into the material. The first thing that I wanted to do was a little bit of a motivation around why this case is a useful case. So why focus on organic agriculture as something that might have some benefit for understanding interoperability issues in the context of AI governance. The first point I just want to emphasize is the long history, particularly with the sort of public and private hybridity of the interventions that have sought to govern organic agricultural practices. The second is that while interoperability itself as a concept and a practice has not received a ton of attention by academic scholars in this area. Other very related terms like harmonization, mutual recognition, equivalency have. So lessons can be drawn. And then finally, I think the case is a useful one because it's a case where standards focus on production processes and inputs that have little or no direct visible effect on the quality of the end product that people buy or use or consume. And in that respect, it's a case that unlikely benefits from self-enforcing or incentives for compliance that come from something like network effects or benefits from everyone doing the same thing. Whereas there are clearly problems in this sector to do with fraud, free riding, shirking, and competitive zero-sum dynamics in the marketplaces where organic agriculture products are being produced and bought and sold. And hence, that raises questions, issues for interoperability that I think are important to consider for the artificial intelligence case. So in the time I have, I want to do really four things. First, I just want to go over some concepts, flesh out a little bit more interoperability vis-a-vis other concepts that I've introduced, provide a snapshot history. I'll spend a little bit of time on this on the organic agricultural case. And then from that case, draw out three lessons, lessons to do with standards, certification, inspection, and accreditation, all pertaining to interoperability, and then reflect by stepping back a little bit and thinking about some conclusions. So first, I wanted to start with concepts a little bit because I think it's important to think about what's at stake here. And I think, firstly, Benjamin did give us a little bit of a definition of interoperability. A dictionary definition of this concept is the degree to which two products, programs, etc., can be used together, or the quality of being able to be used together. And this implies that there are, forms and degrees of interoperability that might involve different configurations of this being able to be used together quality. The other thing that I wanted to just highlight here is that I think it's important to recognize that interoperability itself is not necessarily an end. It is something that we might seek to accomplish in order to achieve some other benefit. So pursuing interoperability as an end in and of itself, we might want to reflect on why we're doing that. Okay, and I think that's important in the context of agriculture, partly because there's the possibility of the threats of races to the bottom or dynamics where we're pursuing equivalency that have unintended consequences for other things we care about. The other concepts that I think are very relevant to think about in this context of agriculture, and they'll relate to what I come to at the end in terms of lessons, is harmonization. So the act of making things same or similar to facilitate this working together. So harmonization is a process by which one can accomplish interoperability. Mutual recognition, again, another similar type concept where the actions of two or more bodies are recognized. They recognize each other's actions or standards within some scope, a predefined scope, such that they have agreement on where and when they can defer to those other regulations, standards, rules. And then finally, equivalency agreements are situations where it's essentially a mechanism that's very similar to mutual recognition, where two parties agree to reduce duplication that might otherwise exist in a regulatory domain. So for instance, an exporter that has to be inspected in two different product export markets. And if you can come up with an equivalency agreement, obviously that reduces the cost for that exporter to not have to be inspected 2 times over. So turning now to the history, this slide has a lot on it. And so I'm going to just take a moment to sort of walk through it briefly. There's 3 things that I really want to draw everyone's attention to. The first is that this is a chronology. So it was an attempt to try to give a big picture view of what's happened in the organic sector over the last century. The second thing is to kind of indicate that it captures both public and private and joint initiatives, not necessarily everything that's happened, but some very salient features of those three domains that I want to draw attention to. So public regulations are the blue dots. Orange dots are the private initiatives, and green dot, there's only one on this chart, is a public-private initiative. And then the third is I wanted to just use this as an opportunity to spell out sort of four phases in the development of organics. And I'm going to start with that to talk through that briefly about what's happened in the sector, and then move from that into the slides that come to distill some lessons for interoperability. So along the top of the slide, you can see four titles. The first is really the early stages of organics, so early small-scale experimentation. This is essentially the period where the ideas of organic agriculture were starting to take form around the world, but particularly in North America and Europe. We saw the Rudolf Steiner in the 1920s coming up with the ideas of biodynamic farming. At this time, there were some small-scale initiatives like Demeter International in Germany, Soil Association forming in the UK, the Rodale Institute in the US. And this was a period of experimentation, small-scale, practice-driven efforts to try to understand the process of organic agriculture. The second period was is the beginning of institutionalization, mainly within the private sector. And this began with sort of subnational and national scales and extended to the international scale in 1972 with the formation of IFOAM, the International Federation of Organic Agriculture Movements, that's listed at the bottom of the chart below the chronology. The third phase is the introduction of rules for organic farming practices and compliance procedures. So this is where governments start to move in. And this is captured by the growing blue lines, the blue dots that go upwards towards the top right of the slide are capturing the number of government interventions in the sector to regulate the standards or the practices of auditing, accreditation, and the expansion of that over time. And by today, there are around 100 countries with different forms of regulation of organic production, certification, labeling, and claims, as well as accreditation. And the fourth period has involved sort of this joint efforts of working together to make interoperability possible across this complex public-private space, where the private has not vanished. It still remains quite active in the organic space. And you can see that in a number of ways playing out over the course of the sort of 1990s forward. And I want to just start by saying like the current organic agriculture sector constitutes about a little over 70 million hectares of agricultural production worldwide, about over 3 million farmers, and is probably worth about 120 billion euros annually. IFOAM itself has about 700 members across 100 countries. And you can see, obviously, the regulated sector has grown quite considerably over that period of time. And the sort of things that I'm going to tee up for the final part of my discussion around lessons is there's a couple of initiatives that are important here. First, IFOAM has in many respects been a success in moving the field towards a common understanding of production standard. But this has taken a considerable amount of time, right up to the initiatives that led to the 2011 ratification of the common objectives and requirements of organic standards and the IFOAM family of standards initiatives, which I'll come back to in the coming slides. So the points there are to remember that the private initiative is sort of led into coming towards a common understanding of production, but this has not been a quick process. This has been a decades-long process. The second area in which there's sort of been success or quite a considerable effort on interoperability has been with accreditation. And so you can see the orange dots that start to grow up to around the early 1990s are essentially individual certifiers that started to set their own standards and certify against those for organic production. So these would include organizations like the Soil Association, California Certified Organic Farmers, Organic Crop Improvement Association, CRAV in Sweden, Oregon Tilth, National Association for Sustainable Agriculture in Australia. And by the late 1980s, there were about 40 private auditors or private certifiers operating in this market with really no oversight by a collective body. And that's where iPhone began building an accreditation system that slowly over time has moved towards a greater and greater share of accreditation over this private sphere. Okay. But the challenge that has remained, that I'll speak to more around the interoperability going forward, is the fact that this process is paralleled by an equal process on government regulatory side. So accreditation has not necessarily been consolidated. You see accreditation occurring within countries as well as this private sphere. Okay. So to distill out of that history that I've just provided, I just want to speak briefly to sort of three ways in which interoperability are at play in this context. So first is sameness and equivalence within production standards, sameness equivalence of certification inspection processes, and then finally, sameness equivalence of the accreditation process. So firstly, with the production standards, as you can see, there's a very long history here. And that this really was a process that began with practices, exchange, and learning, not with standards. And the pressures for interoperability really came from concerns with fraud, uneven playing fields, and consumer confusion. And this is where you saw public, national, regional, so in the case of the EU intervention, but there was a remaining presence on the international scale in the private sphere. So iPhone purposely did not defer to governments because none of these initiatives were at a global scale. So some of the things that have been successes, I would say, on the interoperability front are iPhone's recent initiative on family of standards that have tried to kind of move forward easier equivalency across the public-private sectors in this context, and then also countries crafting bilateral equivalency agreements to facilitate equivalency across their standards. The second dimension here is also kind of the importance of inspection and certification processes. This, again, is a very long history and similarly really began with practices of individual certifiers. And at the time, they were certifiers and standard setters, offering checks to farmers that wanted to make some kind of market claim using some label, so the Soil Association, et cetera. And similar to the standard side of thing, there was a lot of pressure here for interoperability because of concerns of fraud, again, uneven playing field, different standards, expectations across these certifiers, and confusion in the marketplace because there was a multitude of different labels, all meaning different, seemingly similar things. So we've seen public and private efforts to address accreditation, but we see that at the moment there's the private system that I described at length, but we also see individual countries having their own accreditation systems that introduce friction to this marketplace. I'll come back to the participatory guarantee system if there's time in the Q&A. So to kind of take that, the implication of that certification proliferation problem and the public and private is that we have this continued challenge on the accreditation front where we have parallel systems that are operating within IFOAM, the International Organic Accreditation Service, which is IOAS, as well as a multitude of different forms of accreditation that occur at a national scale. So CFIA and USDA are just two examples that have a complete system of accreditation themselves. DAF in Australia have a very different system that only does for exports. So really, this is an area where continued work on interoperability will be going forward in the organic case. So to close out, organics, I think, is an important case because of sort of the competition in the marketplace, but the drive for inspection and certification because of the concerns around fraud or claims in the marketplace needing to be credible. And it also shows that the long history of sort of local initiatives can generate long-term challenges for interoperability that may be paralleled in the AI context. And that it's important to recognize that we can't just focus on the production side, the standard of practice, but we also need to think about interoperability issues on the process of inspection, certification, and accreditation. So thank you very much for your attention.
Thank you. That was great and cool because I haven't learned a ton about the organics case. Laura, would you like to start your presentation?
Well, hello, everyone. My name is Laura DiNardis. I'm very delighted to join this webinar on AI interoperability and discuss something different than our previous speaker, but something where we can also find some commonality. And this is the world of internet architecture. Let me start by just laying out the basic thesis of my work because it kind of sets the stage for what I'm about to talk about. The basic thesis of my work is that arrangements of technical architecture, and especially interoperability, are also arrangements of power. And I study this from the standpoint of being an engineer and a scholar of science and technology studies, and also a lot of background in law. So it's an interdisciplinary area. And I focused primarily on emerging technologies around the internet and the technology governance of that, ranging from the next generation internet protocol, which is called IPv6, to quantum communication, to the Internet of Things, and most recently, artificial intelligence around the internet, and also emerging space context. So it's a very interesting area. What is the problem in the historic context that internet architecture arose out of? There are many generations alive today that remember a time when there was no interoperability between computers that were made by different companies. I like to tell my students about this because it's hard to believe, but if someone was using an Apple computer, they couldn't necessarily communicate with someone using an IBM computer. There was no interoperability. So this really is a technical issue. How do you create that interoperability? There was a need for it, but there wasn't necessarily a clear idea for quite a while of what the solution would be among competing protocol suites. And by protocols, I'm really meaning technical specifications. So when I use that word, I mean the technical standards that I'll get into in a moment. There was the TCP/IP suite of protocols that was in contention with another one that was being developed by the International Organization of Standardization. So this took a long time, but eventually the Internet Protocol, as part of the TCP/IP protocol suite, really became the common protocol that standardized how information could be exchanged, routed, and addressed among the computing devices made by these different manufacturers. So this was a major leap in innovation, and we have the global internet that we have today because of the standardization. An important point is that the internet standards ecosystem or architecture, if you will, is much broader than just IP. There's an entire constellation of protocols that are necessary for interoperability. Some of them, many of these are actually household words that people are familiar with, like HTTPS, standardizing some encryption online, border gateway protocol that standardizes how networks exchange information with each other to collectively interconnect and form the global internet. Some are compression standards like MP3 or JPEG, and other standardized various applications, error correction, many different functions. So it's a collectivity. It's not just the internet protocol. When I say internet architecture, I mean the collection of internet standards that are part of the protocol suite around the internet. I want to suggest 3 reasons that the Internet Protocol has been successful. Why has it succeeded? Well, let me first say that having this success in the common protocol architecture does not mean that there's no fragmentation at all. There always are some kind of resurgences of proprietary specifications. You could argue that there's not fully a global internet now for a variety of different reasons. Some people aren't connected. There's censorship. There are different kinds of cyber sovereignty issues. But in general, the availability of the common protocols has allowed and made interconnection globally possible. Now, what I want to argue is that it's not just about the technical standards. It's not just about the abstract protocols, but it's also interoperability of the surrounding support systems of the institutions of internet governance that run this system, and also the internet addresses themselves. So it's sometimes actually easier to understand the technical complexity than it is this institutional complexity and the systems complexity that makes all of this work. I've done a lot of writing about this, most directly in the Global War for Internet Governance that explains how internet governance works. But there's no one actor responsible for setting the various standards, for coordinating the systems. The IETF, this is just an area with a lot of acronyms. I'm sorry, but the Internet Engineering Task Force is the primary technical standard setting institution, but there are others like the World Wide Web Consortium. There are institutions that run what's called the domain name system that translates between the numbers that computers use to route information and the words that we use, such as CNN.com and other kinds of domain names. And there are many institutions around this. So in other words, the success of interoperability is about the standardization of a common address space, about the common specifications or protocols that define the technology itself, but also the supporting systems that are necessary for keeping this operational and the institutions that govern the systems. So that is a key success factor. Second one I'd like to mention is this term open standards. You could argue that the core internet standards are open in 3 different ways. And I've written a book on this, an edited volume actually called Opening Standards. They're open in 3 different ways. Open in their design, meaning that anyone can participate and do so in a procedurally open way. They're also open in implementation, meaning that any of us here could access the standards. We could go to what are called the Internet RFCs. It's an archive of Internet standards and proposed standards. We could look at them, we can use them. And let's say Graham and I just wanted to go to a new career and start a new company. We would never make a product unless we were assured that our product could interoperate with competing products. So in order to do that, we would need to access the standards, create the product, and we would want to do that in a way that is not hobbled by royalties. And that's part of the openness and success of the internet standards, in that they're made available without significant intellectual property rights restrictions. And then the result is that they're open in their use, meaning that they result in open, multiple competing implementations based on these core standards. And then the third one I'll mention, and just to recap, I discussed one around the governance and the systems. I mentioned one around the procedural openness and the nature of open standards. But then, of course, the technological affordances are a factor. IP rose to prominence because it worked. This is a philosophy called working code. If you interact with the Internet Engineering Task Force, there was voluntary adoption of the protocols, in part because they worked, they were demonstrated. It wasn't just people, sitting around and talking about what might happen, but developing standards and making products that worked around this. There was a necessary common addressing system that helped to provide the global interoperability. That is a technical issue. And then the protocols were designed to be general purpose and flexible and upgradable over time. So these are, in a way, technological affordances. And I also mention this because the technological affordances that have succeeded have also attracted global challenges and conflicts. And I think this is an important point because you can envision how this could happen in the world of AI in many different ways. So a couple of examples. The domain name system and IP addresses, in a way, create a choke point for control. So you could block content at that intersection of where the domain name system translates between what we use, the words as humans, and the IP addresses or numbers that computers use. So this has long been a way to enforce intellectual property rights. You can block access, redirect to a law enforcement site, and also you could use this to censor information, and many governments do. There's another success factor that has attracted a lot of geopolitical conflict, and that's having this finite pool of internet addresses. Now, when I say finite, the original long-standing version had 4.3 billion addresses, and the newer version has many, many, many more than that. But it is a finite pool, and in part because of that, there has been contention over who controls the distribution of that. I could spend 10 hours discussing the contention over this, and I won't, I promise. But one example is the transition from US oversight to a global multi-stakeholder institution. Maybe one more of these. Let's talk privacy. The unique addresses create virtual identifiers that are not physical identifiers, but when combined with other information, such as something that you could access from a network operator, they do create privacy concerns because they can be used to identify people. And in fact, if you read the terms of service of any application online, you see that IP addresses, that's one thing that's gathered about us. And it really creates a de facto identifier of people. So these are just a few examples. And at a higher level, just given the central role of the internet protocol architecture on the digital economy, on the public sphere, underneath as the substrate even of AI, and really every facet of the real world now connected through the Internet of Things, you can see that it's really unsurprising that economic and geopolitical forces seek to control, or in some cases, replace this technology. What does this all mean to AI, finally? Putting this all together, we really can have some lessons for AI interoperability from the world of internet architecture. The first one is about technical complexity. It's really impossible to discuss anything without understanding the thing that we're governing or that we're trying to establish interoperability for. Yet sometimes when we talk about AI, in the same way as we talk about the internet, we talk about it as one thing, but it's not one thing. From the chip architecture to the large language models to the cloud computing infrastructure, this really is a diverse area of technology in the same way that the internet is a diverse area of technology. So this brings me to the second lesson or point, that there's sometimes an overfocus in both of these areas on content and applications. This is a problem in international discussions, from the G7 to the AI Safety Summit and everywhere in between. There's a myopic focus on generative AI, and this is very similar to the focus on social media in the world of the internet, at the neglect of the 99% of the infrastructure that can't be seen in the same way that content and applications are seen. So this can't just be about content, the interoperability. It has to be more than just a few companies, more than just a few technologies, and it has to be treated as the infrastructure that it is rather than just about the content level. Third quick point, while we're talking about a lot about content issues in the international governance sphere, infrastructure is always politicized. It will be in AI, and in fact, it already is now, and co-opted for geopolitical goals. There are many, many examples of this. Not that long ago, the Department of Justice here in the United States uncovered a Russian influence campaign that used generative AI to create deceptive content, and then it tied to a false URL, or which is the in a way the website that people would access. So instead of NATO.int, it was NATO.ws. So people didn't know the difference. So you can see the merging of AI and infrastructure and how that's being co-opted for various things. So that is a lesson. Fourth point is that there seems to be a perfectly common something in common between the two areas, and that's that there's an AI clash between multilateralism and multi-stakeholder discussions about interoperability and governance, very much like around internet governance. So this is a problem. There's a sudden jolt away from multi-stakeholder system discussions. In some ways, the private sector is not reflected in international discussions. In some ways, governments are not included in other discussions that are primarily the private sector. Many things, though, are coming up multilateral. This is exactly analogous to pressure in the internet interoperability framework, where there's always this tension between multi-stakeholder discussions and actions and what now is usually called cyber sovereignty or digital sovereignty. So we can expect the same thing in AI. And then finally, my last point is that the cyber and AI communities really have to converge. You can't talk at all about cybersecurity anymore without knowing and understanding the integration of AI within that realm. And you can't talk about AI without discussing cybersecurity, addressing schemes, and other kinds of interoperability functions around cloud computing, security, and other areas that come from the world of internet architecture. So these are very entangled, but the communities are different. And this will be a problem that has to be solved. I believe that this discussion today is, in that solution area and not in the problem of bringing different communities together. So to summarize, the AI interoperability, very much like internet interoperability and the governance issues around that, it involves complex technology that extends far beneath content, all in the context of the politicization of infrastructure, in the context of tensions between multi-stakeholder and multilateral approaches, and then challenges that always arise from the siloed communities that need to come together for the common good. So thank you very much for listening, and I look forward to your comments and questions.
Thank you. I'd be interested to hear more about the contested domain name distributions control, but perhaps later. Gary, would you like to share your screen and present your case?
Sure. Delighted to be part of this discussion. It's really interesting how this quest for interoperability sort of plays out so differently in these different technology domains, depending on the sort of the specific context and factors in each domain. So I'm going to talk about nanotechnology. And nanotech resembles a lot to me the way AI has come upon us. Like AI, nanotech was first defined in the 1950s, but just sort of lurked there. It didn't really move very much in terms of industry or scientific advancement. There's really no interest in the governance of nanotech for many decades. And then early in the 2000s, it just exploded with all these different applications and types of nanomaterials suddenly becoming commercially available. Basically, every major company was using nano for at least one or more projects. And it became sort of the main focus of governance, and all these grant programs and ELSI programs and so on all spun up to become the next big thing for both technology and industry, but also the governance and ethical, legal, social aspects of technology. So it's very similar to AI. I think AI is even more, ubiquitous and broader, but it's a very similar sort of just a sudden explosion that occurred. And what was interesting is that all the different countries, but also groups within countries, all talked about the need for international coordination. It became a big focus, and everybody would have that at the top of their list of one of the key priorities for governing this previously non-existent regulatory system for this technology. But there was a lot of uncertainty. No one really understood a lot of the risks. We still today don't really. There's so many different types of nanoparticles. For example, there's over 50,000 different carbon nanotubes. Some appear to act like asbestos in the body. Some seem to be completely inert. So just really messy, complicated science, many different types of nano materials. And so we really didn't know how big of a risk this really was, and where the risks were. Another interesting thing about it, David Levy-Farr said that this was sort of the first example of a technology where we really started talking about the governance at the same time as the technology came about. I don't know if that's true, but I think that may be true. I remember going to the first big nano meeting that was sponsored by the NSF at the University of South Carolina, where the head of the National Nanotech Initiative said, unlike other technologies, we're going to get ahead of this one right before the technology gets here. We're going to have all the regulatory ethical issues resolved. Of course, that didn't happen. Maybe simultaneously was a better chance, but I don't even know if that succeeded either. And so there's a lot of difficult challenges to traditional regulation of this. There was no good definition that was legally enforceable. There's all this uncertainty. There is no test methods or ways to measure these in the environment or in the workplace. It didn't really fit with a lot of existing statutes. It was moving so quickly, it was very hard for regulators to keep up with it. There's a big debate about how the risks compare to the benefits. For example, many clean energy technologies are using nanotech. So there's a huge amount of environmental benefits, but there's also environmental risks. And just like with AI, we ended up with not a lot of action at the regulatory level at the national state. And so, as this article by Terry Davis argued, a longtime EPA person, yeah, traditional regulation isn't going to work, but we need some kind of oversight because people could be getting hurt by this technology that does present risks, both environmental health and safety, but even some broader social risks as well. And so this is a model we developed of sort of this idea of moving from sort of soft law, informal mechanisms to hard law regulation, that even if it wasn't possible to regulate right away, there were different types of programs that could be put into effect that would eventually give us the information to allow us to move to a more real regulation system. And this is Ken Abbott had this way of looking at these soft law programs based on who was involved, civil society organizations, government, and industry. And these are just some of the major soft law programs that emerged with nanotechnology that involve both industry, NGO community, and government. And so there's all these different initiatives all being sort of played out at the same time with different goals, different participants, and so on. We received, Ken Abbott and I, 2 successive grants from the Department of Energy to talk about international governance of nano. Again, this was a high priority. So one of the things we did is sort of just look through all these government documents and so on. Why were people saying we needed international harmonization? And there was a lot of different reasons given. One was to facilitate international trade. One is so that companies could have the same workplace and environmental controls in different facilities around the world. One was a concern about these hazardous products crossing national boundaries. One was, again, concerned about trade barriers. Some were concerned about race to the bottom and risk havens. Some wanted to create economies of scale for regulators because they're all sort of starting off with very little knowledge about this, be able to share resources. So there's a lot of different reasons given for why international coordination or harmonization, whatever word you want to use, was seen as a priority. And it was sort of these 6 factors that were driving that. This is a very prominent and influential study that came out from the London School of Economics, sort of talking about 100-page document, why we need international coordination or harmonization of nano, and then really concluding with these sort of 3 mechanisms. One would be treaties, and that went basically nowhere. Maybe some stuff through trade, but that's about it. But really what happened is in these other 2 categories of policy diffusion, of informal communications between regulators, and then these international sort of soft law mechanisms that were really the core of what ended up being the governance for nanotechnology at a global scale. And so there's a number of different initiatives that were launched sort of all simultaneously. One was from a Meridian Institute, an NGO in Washington that was funded by the NSF to create a dialogue meeting of regulators from over 25 countries who gathered for a 3-day meeting in June of 2004 to talk about common issues. And the idea was not to come to any formal agreements or anything, but an opportunity to get to know each other, but also to discuss some common challenges they were all facing. And over 100 regulators from these 26 nations attended. It wasn't attended by NGOs or industry people. It was just government people only. And they ended up having 2 more of these meetings, one in Japan, one in Europe, and then it stopped. But according to all the participants who reported on it, this was extremely helpful for them to talk with colleagues and people doing similar issues in other countries about the same issues they're facing, of how they're defining nanotech, how are they differentiating it? Should you have special regulations for nano compared to non-nano? And so it did make a lot of progress in terms of helping to create this sort of community among the regulators, at least. One of the things the government of Canada and US did was this a Regulatory Cooperation Council to coordinate US and Canada regulation. And as part of that, they funded a project by Mark Sainer at University of Ottawa and myself to do a survey basically of people involved in international governance of various technologies from industry, government, and NGOs. And one of the findings we had, which surprised us, was that this idea of informal engagement among regulators was seen as one of the most important ways to promote international coordination and harmonization. Just that these people knew their contemporaries in other countries, could call them up or send them an email, knew who the person was, and be able to discuss and trust, that they're dealing with very similar issues. And we were surprised how high that ranked as sort of the leading, particularly by regulators, the most important way to promote international coordination and harmonization. Another big initiative that got a lot of fanfare came out of Britain. The Royal Society issued this report in 2004, which is extremely influential, saying we really have to have upstream engagement. We have to have anticipatory regulation. We can't, wait till this is out on the market and people are being killed like with asbestos. This can be very dangerous. So we really need a more proactive, anticipatory, sort of responsible research approach. And in follow up to that, they coordinated with this sort of nascent nanotech trade association called the Nanotech Industry Association. This group had a hard time really getting much foundation, the trade association, because all the companies making nano were already in different trade associations. The chemical industry, the auto industry, the medical companies, and on and on. They already had their own trade associations. So it was hard to get people to be willing to pay fees to be a member of a nanotech industry association. But anyhow, there was such a thing. And they worked together with the Royal Society and a whole bunch of other individual companies and a whole bunch of NGOs to put together a voluntary regulatory governance system that was called the Responsible Nano Code. And this was launched in 2008. And it didn't really go very far. There was a dissension right away about whether there should be a follow-up document to create more enforceable specific requirements. The requirements of this thing were very vague, and they expressly said, this is not an enforceable commitment if you sign on to this. A lot of the NGOs in particular wanted something more specific and maybe enforceable. Companies pushed back on that. The Royal Society ended up pulling their funding. They didn't have more funding, and the whole thing fizzled out. So this didn't really go anywhere. It was an interesting experiment, but it didn't really proceed. Something that was more successful is the OECD created a working group on nanomaterials. And this group was, again, just really government officials from all these different countries who developed a program of 8 different projects, things like testing representative nanomaterials and so on. This program was quite successful. For example, none of the countries had any data on any of these nanoparticles, and there's a lot of different ones. So what they did is they basically parceled out that each country would take the leadership in different products and undergo a testing program using common protocols, and they would share the data with the other companies. So this saved a lot of money and effort, again, allowed them to be much more efficient by getting all this data much more than any one country could do. And this coordination through the OECD has continued to this day. These are just some of the more recent reports. They've developed test methods and continue to basically work on sort of the technical side and trying to harmonize those technical protocols and standards that different countries are using for safety. And this tour to table they do every year of what each country reports on what they're doing on nano, and they consolidate it all in this single report. Again, I think very helpful. It continues a good way to help promote coordination. Another initiative that got a lot of eventual impact, but not initially, the CEO of DuPont, a major company, and the CEO of the Environmental Defense Fund, a major environmental group, co-published an editorial in the Wall Street Journal saying we need to be proactive in governing nanotech because we don't want another asbestos. And their scientists got together and produced this thing called a nano risk framework in 2007, which is basically a very detailed manual of how you evaluate the risks of different nanoparticles. And this didn't go very far, and DuPont used it, but not in others didn't use it very much. But then insurance companies glommed onto this, and insurers were concerned about long tail risks that they experienced with asbestos. And a lot of insurance companies started requiring companies using nanomaterials to either follow the DuPont EDF nano risk framework or the equivalent. So they started imposing this requirement as a condition of getting coverage that you had to have a risk management framework in place for nanomaterials. This then led to the ISO basically adopting the EDF DuPont nano risk framework as a standard. This was, again, a very, I think, significant move because up until then, most international standards were working on things like interconnectivity and so on. There was the ISO 14000 environmental sustainability that were before this, but this was one of the very first standards, I think, that was really a regulatory standard. This is basically displacing governments. It's basically putting in place risk management programs in the workplace that normally would be something like an OSHA or a regulatory agency would do, but regulatory agencies were just sort of unable to move. They were, for various reasons, unable to do this. And so basically this ISO stepped in and put in place essentially a quasi-regulatory standard for risk management. And we're now seeing that again, for example, with AI, of all these sort of governance type standards for AI that traditionally would have been done by governments, but because governments are failing, these private standard groups are filling that gap. And today there's something like over 140 standards issued by ISO on nano, and there's all kinds of other ones by other standard setting organizations have likewise put out these private standards that go beyond, interconnectivity and so on to really be more of a health and safety governance programs. And it's caused somewhat of a confusion in the field because, again, a lot of companies in this space, particularly smaller companies, they don't know which of these standards they should be following. It may not be plausible to follow them all. And so you've got this proliferation of private standards, but yet these remain in effect today, and I think are the primary governance mechanism in place for nanosafety today. Again, government regulation has lagged, continued to lag. We still don't know what's dangerous and what isn't, but these programs exist and are maybe the only real effective governance in effect at all. So the World Economic Forum, looking at all these programs, said that governance and business have begun to address the potential safety concerns. There's been this movement. It all seems very good. A new paradigm of responsible innovation, but they said, despite the best of intentions, we don't understand the risks to this day, and we don't know what's safe. We don't know what the best strategies are. So we're still living with a lot of uncertainty, and frankly, that's continued right to the present day. Ken Abbott and I, a little bit more positive. We wrote a few articles evaluating these programs saying, well, the impact of these programs is undoubtedly positive. The extent of the protection they currently provide is, with a few exceptions, very limited. Notwithstanding the limitations of the current programs, an experimentalist approach is well suited to identifying substantive and organizational lessons from diverse programs, whether individually they succeed or fail, and to promoting learning that can lead to incremental improvements. And I think that would also apply to AI, that we have all these different soft law programs in effect, particularly in the US, where we don't have any real government regulation. It may not for some time. That's really going to be our primary governance. And the question is, how do they relate to each other, and then how do they relate to what's going on in other countries? So I think there's a lot of lessons from the nano, just like the other case studies for AI. And with that, I'll stop.
Thank you, Gary. And to people in the audience, if you do have any questions, do feel free to put them in the Q&A, and we'll get to them shortly. Cornelia, did you want to start? You're muted.
Yeah. Okay. Let me quickly bring the slides up and okay. Okay, so thanks a lot for having me in this panel. It's super interesting to hear all these different sectors and experiences. So my name is Cornelia Kutter. I'm Managing Director at Considerati and also Senior Advisor of Safer AI. And I also have a research role on AI regulation. However, here I'm actually talking about telecommunication interoperability and what we can learn from telecom interoperability, which relates to former roles I had, and I'll explain this also in a second. So what I'm going to do is I will shortly talk about traditional telecommunication interoperability, but then I will also look at more modern interoperability regulations in the telecommunication space focused on Europe, and how I believe there is quite some similarities with specifically agentic AI and what we're seeing as needs in this space going forward. I think much of what I'm talking about is sort of a build up to Laura's presentation, as she was like a little bit lower in the tech stack. I do actually indeed talk more about the application layer in this space. So clearly, we all phone with each other, and telecommunication, just go because I need to put this a little bit down. So telecommunication interoperability has been very successful and rests on decade of collaborative standardization. I think there is some similarities of what we have heard before. What really has driven this achieved universal connectivity is a number of success factors. First of all, and I think we heard this before as well, consensus-based development standards emerging from a multi-stakeholder process rather than a single vendor dominance. Also some backward compatibility across, for example, 5G networks. There's also an incremental revolution. Technologies have evolved incrementally, which allows also market adaptation, and the economic incentives were aligned. So everybody has benefited from this expanded network reach. The technical focus standards address always technical challenges without necessarily premature convergence on business models. And again, this is important in the context of these more modern regulations. So the pillar of interoperability is basically the standardization, the interface compatibility, the data exchange protocols, and regulatory compliance formed the foundation of this success. Why it matters? Of course, we have global connectivity. Again, Laura already talked about the IP protocols, for example. There is a sense that common standards foster competition among telecom providers, spurring innovation and improving user experience. Also, there is, of course, also a bit of a tension between standards and innovation. We have seen a variety of technical standardized services and products that were not necessarily superior to others. In the telecom interoperability case, there's also the internationality of roaming, so that subscribers remain connected when they move across borders, and the network expansions that allows this integration of new devices. A model for technical governance in this space is 3GPP. This third generation partnership project, which was established in '98, has been basically a global scaled technical standardization efforts of regional telecommunication standardization organizations to continue preserve these innovation incentives. So these are 7 regional standardization organizations that very regularly innovate and update standards. Again, these are also consensus-based decision-making across diverse stakeholders. So now I'm moving to the European regulatory framework. And there we have really interesting developments in the context of telecommunication interoperability that were not necessarily driven by only the technical or the technical needs, respectively, improvement for users. In fact, much of the electronic communication code at the time, around 2017, when it was negotiated in the decision-making institutions of the European Union, the Council and the European Parliament, there was quite a non-market driven incentive, which was the traditional telecommunication providers saw an enormous new competitor with over-the-top communication services like WhatsApp. And they have very much pushed sort of to include over-the-top communication service providers into the broader electronic communication code, which is largely either consumer protection or market regulation. We'll get to this in a second as well. So in this context, Article 61 allows national competent authorities, so this is nationally enforced, to impose interoperability obligations on over-the-top communication services, which are not number-based. The rules, however, only apply if national authorities observe that there is a market failure and potential harm to consumers. So this is a reactive, a post-market regulation that needs to demonstrate market failure before intervening. Hence, so far, this rule has actually not been applied. The reason might be, and let me go back, also that the telecommunication regulators are very risk averse, and so they have refrained from enforcing or imposing this specific rule. Now, a similar rule has been adopted with the Digital Market Act. So surprisingly, we have a similar, the same services potentially covered both under the Electronic Communication Service and the Digital Markets Act. Just more broadly, what is the Digital Markets Act? It has been basically a shift from this ex post to ex ante market regulation for certain services. The Electronic Communication Code is obviously largely a market regulation for electronic communications, so for telecommunication services, while the DMA is looking at a different set of sector. It includes cloud providers, operating systems, but also communication services, etc., or app stores, for example. So only gatekeepers have to comply with these rules. I am not sure whether everybody in the audience knows about the Digital Markets Act, so just the basics. you are designated as a gatekeeper if you're from your services in scope, if you meet quantitative and qualitative thresholds. So you have to have an annual turnover of 7.5 billion in the last 3 financial years in the European Economic Area. You have to have a global market capitalization that equals or at least 75 billion in the last financial year. And you need to provide this core platform service, as it is described, to around 45 million monthly active users within the European Union. So that's sort of the baseline. We have 2 interoperability obligations in the Digital Markets Act. And Benjamin, just you need to tell me if there is a question or something, because I can't see you anymore. So I continue here. So starting with the first, it's regulation for horizontal interoperability. So that is basically interoperability between same services. Article 7 mandates gatekeepers to provide messaging services, to make these interoperable with third-party services such as WhatsApp, iMessage, Google Message, and this obligation can be implemented in phases. So it is recognized that this is rather a technically daunting exercise. And so the rules foresee that depending on what specifically is meant, such as one-to-one messaging or group messaging or video and voice calling capabilities, that there's different phases in when those gatekeepers have to comply with these rules. There is a number of obligations. So it is foreseen that this helps with competition aspects of these gatekeepers that have enormous network effects, and to open their messaging platform, breaking basically these wallet guarding and boosting user choice, but also access to the market by smaller competitors. The interoperability must preserve, however, end-to-end encryption and user privacy, and this is a very complex issue, and has also led to forestallment of the application of these obligations. And it has to be developed under open standards and open governance protocols. The rules generally are very user-centric, but again, in the implementation, this is a much more complicated issue, and we have seen quite some gatekeeper resistance. So just as an underlying point, these rules are applicable since May 2024, and the Commission has started to monitor application since then, and has also issued already some decisions of non-compliance with these rules. And then there is maybe on this, there is an interesting aspect that during the legislative discussion, it was actually foreseen that social networks, so social media networks, would be part of the interoperability, but that was then taken out. So that's not a service covered by the DMA. However, there are voices in this space that believe that this should be expanded. This is important because there is some similarities again between social media networks and agentic AI or simply chatbots in this space. Okay, then there is another interoperability obligation in the digital market, which is vertical. So Article 6.7 requires gatekeepers that control operating systems or virtual assistants to ensure free and effective interoperability between the hardware, software, and operating system features and those of third-party hardware and digital service providers. Those gatekeepers must provide technical interfaces for solutions that enable third-party products and services to interconnect with their systems as effectively as their own, ensuring a level playing field. So the main goal here is, again, to reduce lock-in, increase competition, and allow users and developers to switch or combine products and services more freely and without artificial barriers. You can imagine that specifically in the vertical space, there is, of course, a lot of resistance again, but also an enormous market interest to have these rules properly enforced, as there will be a number of competitors really benefiting from this, or not necessarily competitors here, but market integration that might have been otherwise blocked for certain reasons that are not specifically related to the technical measures. And so far, it is not surprising that just this year, in March 2025, the Commission has issued a decision on these interoperability decisions, and has basically concluded that Apple, as a designated DMA gatekeeper, has not so far met the requirements as seen fit to enable interoperability. And so this initial proposal of Apple is basically in the Commission's regard insufficient. Apple has so far been demanded to provide third parties with the access to the core iOS features under fair, transparent, and non-discriminatory terms. And of course, should Apple not comply with these new findings and requirements, there might be further fines that the Commission could impose. This is basically the specific provision that is currently really enforced. When you look at these communication service and more modern services interoperability regulations, they have different scopes. They have very different focus, but they also have challenges which are fairly similar. So there is always a bit of a trade-off between standardization versus proprietary APIs. They all have real issues with balancing the opening up of the interfaces with privacy and security and usability concerns that was mentioned before as well. And the gatekeepers, and these are obviously only a few companies that have been for their specific core services designed as gatekeepers, also are, how can I say this? Some are more resisting than others in actually opening up their and complying with the obligations. So what we are seeing in this space is a lot of resistance of companies to provide this interoperability, and this is eventually the biggest change or the biggest difference than the typical traditional telecom. I think I need to speed up. So very quickly, because I think one can think that the services are not so different. So the question I have maybe for this interoperability, are we not seeing the AI applications becoming much more closer to other core services as they are currently regulated under the DMA. And also, obviously, they all have also communication abilities. So there is a lot of service parallelity. And so it's interesting in how interoperability of agentic AI systems now function. The complication here is obviously that agentic AI does not need specified human operators. They can set their subgoals on their own, and they also multimodal. So they are, as such, a much more complex system than just like a social media or communication system that is only voice. However, there's already some protocols developed. These are private efforts. One is the Model Context Protocol, developed by Anthropic, that enables different AI integration system with a architecture that basically allows LLM applications that users interact with to be hosted and to connect managers within the host application. There is obviously, as I said, similar security concerns. So the Model Context Protocol takes into account security as inbuilt in security by design framework, which requires user consent for all data access, explicit authorization for tool invocation, and privacy controls for sensitive information sharing. And then we have a similar, another protocol is the Google A2A framework that addresses the coordination challenges with multiple AI agents. What is important here as well, that it is open, but starts to try to address these interactions and has, of course, more challenges as AI decisions are probabilistic, requiring coordination protocols that can handle uncertainty and conflicting agent objectives. So this agentic AI world is likely to be a real challenge for interoperability. What is interesting, and this is sort of like the conclusion, there is similarities, as I alluded to, between Article 7 of the DMA for messaging and potential agentic AI interoperability needs. One is, and we will have to see whether there might be the risk of vendor lock-ins. We think about yesterday's, I mean, there is certain providers that have an enormous market coverage. So we'll have to see a little bit how this evolves, whether there is a need for regulation or whether this can be dealt with in the interest of everybody by multi-stakeholder approaches. It will have to be seen. But the technical focus, the privacy and security concerns are quite similar. On the one hand, the privacy has to be preserved either through end-to-end encryption. On the other hand, you have to secure, it was alluded to on the cybersecurity space, you have to be sure that to safeguard them against the most modern threat models of frontier AI. Here I mentioned prompt injections, but of course the risk profile will evolve significantly. And there is also comparability with the Article 7, because in the vertical interoperability, that might well be needed if you have agentic AI that is very diverse. So there, I think there is the comparability is probably more with Article 6.7 with Article 7 than with Article 6.7. But the question that can we learn lessons from the DMA for agentic AI interoperability? There are similarities. The risk for vendor lock-ins could be prevented. The security and privacy by design concerns are very similar. And so as long as these privately developed protocols follow like fair, non-discriminatory access and open standards and user consent and control in the interaction, it's to be seen whether regulation is really necessary. Similarities are definitely here. Many learnings probably from those regulations. And I think this is the end of my presentation.
Thank you all for the presentations. So we will move into the discussion section now. I have a list of sort of broad questions to ask you guys, and then we have a handful of questions from the audience that we'll get to after that. So I noticed across the cases that there seem to be the same actors appearing, like ISO, IEEE. Oftentimes they were standard setting bodies, mostly international standard setting bodies. And a similar set of actors has arisen at the outset of the AI governance or AI standardization efforts. So how might this initial private actor influence followed by seemingly public actor influence sort of get at the interoperability work? So we saw similar things that Graham mentioned in the organics case, where there was this initial private sector or private efforts and then a increase in public sector laws. And the same thing was sort of alluded to in the nano case and the telecommunications case. So I'm just sort of curious what you see as similar between your cases in the AI space and how this might lead into regulatory or technical interoperability. Gary?
Well, so I think like looking at the nano case, there's a whole bunch of initiatives, and all the ones that were outside of existing established international organizations fizzled out. So the Responsible Nano Code was sort of sui generis, create this new organization, this new program from nothing, and it fizzled out. It lacked funding. There's disagreement. The Meridian Institute thing, even though it had some federal government support, worked for a couple of years, but then it fizzled out. Where the DuPont EDF collaboration, I don't think that would have gone anywhere until it was adopted by ISO. So it seems, at least from the nano case study, that getting it established within these large organizations like OECD, ISO, and so on is critical, because sort of standalone, create these new novel institutions or programs aren't going to be able to continue, have the stability and the long-term funding to be able to be a long-term solution. So I would argue that might be similar to what we'd expect in AI. We see all these initiatives popping up all over the world of AI governance. I think if they're not within one of these existing established organizations, they're going to have a hard time staying sustainable.
Cornelia, you have your hand up as well. Do you have a point to add?
Yeah, maybe just one point. I mean, it's interesting that Gary mentioned sort of the governance, and there is this is sort of a different level of interoperability between rules and laws. What I would like to, and this deviates a little bit from the point Gary was making, but when it comes to the motivation why we do have interoperability rules versus rules developed by the companies on their own, I think it's really interesting that you have in some of the services really resistance to be interoperable. The same company, however, might in another space really push for interoperability. So ultimately, I think it is economic decisions that drives the positioning of companies in this space.
Laura?
One quick addition to that is that and this is really just meant to be thought-provoking to myself and maybe to others. It's possible that the word AI is going to go away altogether in this space when you think about AI interoperability, in the same way that we don't have work on digital interoperability, right? AI is something that is in everything. And so you have to ask, do you start from the standpoint of AI standards, whether it's the older legacy institutions doing it or some kind of new consortia and engaging in this work? Or do you just say, well, what is the area that you're talking about in standardization in a more technologically complex way? Is it risk management? Is it the work using AI and the web through the World Wide Web Consortium, or something else like the IEEE? So that's just a question. Is this term, right now, the term AI interoperability is incredibly meaningful, and it's an important area and a problem that needs to be solved. But from the standpoint of AI standards, I think that term is going to go away because it really is just something that's integrated in other parts of technology and governance areas.
Graham?
Yeah, that's a really interesting final point, Laura. I think I agree and I maybe disagree in some way, and I'll come to that in a second. But to come back to the original question, I think, Gary, an important point to think about here is like what are the benefits of these? Like what is it that interoperability generates, right? And I think some of the cases highlighted that there are many benefits from having shared platforms, ways to exchange, working together does create network effects, to Cornelia's point. But there are other cases where there's going to be competitive interests in not sharing and not having systems that interact. And I think that from the business or the private sector perspective, like thinking about how standards are sustained, that they may be sustained differently depending on what kind of benefits the private sector is generating from them, right? So this is where something like a club model might be useful for thinking about certain forms of standards. If a club, like this is sort of the model applied to responsible care, to Gary's point about like why the responsible nano may have failed. Well, maybe there wasn't a club there that had a collective reputation that could benefit from excluding bad actors from it, such that they could have a benefit from being in the club versus those that were being excluded from it. So I think some of these standards issues may be more like the benefits from the private sector may be more club-like. Sometimes they're going to be more private benefits where they actually want to exclude others from using the standards so that they can product differentiate in a very specific context. So in that case, then the sustaining the standard is more so that they can say, we're different, we're better than others. So depending on the sorts of issues that we're dealing with AI, I'm not sure it's not just one set of problems, it's a host of different kinds of risks and issues. So what would sustain standards and what kinds of standards organizations might exist may range from an individual company wanting to present itself as ethical in an AI context and want to differentiate itself from its competitors, an industry association doing so, a group of companies doing so, or ones that see benefits collectively in having a standard set of operating procedures so that they can work together. So I think that's another way of thinking about the question, which is more, and which would lead to different ways in which and reasons why a standard would be sustained. But to Laura, your question, which I think is a really interesting one, is that I think the places where maybe AI will remain a focal point is where there isn't an existing sector or set of regulatory initiatives that it can situate within. So, for instance, if I thought about the environment, right? So there is discussions about the sort of sustainability footprint of AI. So in that case, maybe you could think about it going to being taken up by climate initiatives or other environmental regulatory bodies. But if there isn't one that exists naturally already, you could imagine some organizations wanting to frame the problem as something new and distinct to AI, such that it would then be an area in which they would create or focus it, like for strategic reasons, you'd want to differentiate AI from other areas or other aspects of that technology space so that you could have specific environmental, social, ethical standards that would apply to AI. But it's a great question. That's just a kind of a counterpoint to your line of reasoning around it vanishing as a term.
Anybody have any follow-ups? Laura, I just saw that you unmuted.
Oh, yeah, just another follow-up. If you were just thinking about it from a technical complexity standpoint, and even if you acknowledged, and I think there is a lot new about AI, so many interesting things, but if you like AI is not one thing, right? The technical complexity, how would we break it down if we could break it down into different parts? You can't talk about AI without talking about the chipset, for example, the chip layer upon which everything depends. You can't talk about AI without talking about the large language models and machine learning, which is applied in a variety of different contexts. There's the infrastructure of sensors. It ties into the Internet of Things very directly because of the sensors that feed in, whether it's through drones, through cyber, through satellites, physical sensors, that feed into it. And there's a lot of standardization around that. Never mind the weapons, autonomous weapons, autonomous vehicles. And then the communication infrastructure, it ties very directly to what Cornelia was talking about. And it runs over the telecom infrastructure and some of the things I was talking about. There's the access layer of who can gain access to AI. There's many dimensions of cybersecurity. So I think if we were on a whiteboard, and jotting down the different constituent parts of AI, and then creating a matrix of the different standardization efforts, it gets very, very complex very, very quickly. And if you look at that, AI kind of disappears. But just an interesting, it's an interesting point theoretically, but it does have application in terms of where governments should invest their efforts in the standardization. So interesting point.
Any other follow-ups? So I have a follow-up question. So you guys sort of mentioned that there's these different sorts of standards at play. There's product standards, service standards, technical management, so on. And we see you guys mentioned that across your cases, but we also see these and other types of standards emerging in the AI space, like ISO 40001, 40006, 7, IEEE 7000 series, and others. So do you see this like contributing to the problem of this like fragmentation, convolution of too many standards? Do we need to navigate these different types of standards? Is there going to be some level of standards war? Something to that effect. So like it seems like each of these other industries has sort of navigated these problems or hasn't had all of the types of standards at once, whereas AI seems to. I'm just sort of curious how you see that, how you saw that play out in your case versus what you may see going forward in the AI case. Cornelia?
I can give one example, which I know a little bit better, but just again to Laura's point, think this is another type of, while we were more talking about technical interoperability, what you're alluding to is sort of the interoperability between different frameworks, so that those that are addressed by those regulations don't have conflicting obligations to fulfill. And interestingly, while the EU is usually advancing very quickly with regulation, in the context of standards, at least, the AI Act, whatever you might think of it, which is a different discussion, but at least there is, in some recitals and in some provisions of the AI Act, the request, while there is, due to European law, the need for having a European standard, the request that the standard has to be as aligned as possible with international standards. So within the standardization process, there is a lot of effort. So this is the Senelec that is currently developing the respective standard, that it is aligned with others. So there is if you like, a little bit of an interoperability by design already foreseen. That doesn't mean that it will be the same, because there will be additional requirements that are not covered by international standards.
Any other thoughts from anybody else? Oh,
Yeah, I'll add a quick dimension to that. If you split it between short term and long term, I think it's helpful. So in the short term, if you follow the trajectories of other fast-moving technologies over history, it's not a bad idea to have this competition, because it avoids premature lock-in to innovation. It allows for maximum innovation, and the competition can be very good. But it creates immediately in the midterm problems where you have compliance overload as they start to take hold, regulatory complexity. You have it's very resource intensive for the variety of institutions and companies that are involved in standardization to send people to these forums, to spend the hours and the money involved in this. And it can lead into a competition that ends up sucking all the resources rather than having the harmonization that's necessary in the long term. So if you think about it in the short term, it feels like other, rapid or early innovations where there's competition, and hopefully the innovation that comes in, I think it is coming, but you can quickly see how their harmonization is better in the long term in order to reap the kinds of interoperability rewards that have come from these other areas that we're discussing.
If I could just jump in there too. I mean, it's interesting that standard setting organizations aren't very coordinated themselves. I remember reading an article about the ISO 14000. And so what these standard setting organizations do is they create a committee, and that committee then is open to any proposals from their members of new standards. And so they're constantly getting all these different people proposing different standards that often overlap or conflict and so on. And so I remember, like, in the 14,000, there were some like several hundred standards being developed that were all overlapping and in tension and so on. There was nobody saying, hey, does this one, is this needed? Is this already overlapping with this one? I've been involved in the IEEE, and the same thing. They have an AI committee, and anytime anyone submits what's called a PAR for a new standard, they approve it, even though many of them are overlapping with ones that are already underway. So we have all these different standards all trying to do the same thing, even from the same organization, because it's not like a government agency that would be, we have one regulation for this and one for this. It's sort of open field, once the committee's been created, it's open, anyone can propose from within that group a new standard, and all kinds of different people do. So there's not a lot of coordination even within a single standard setting body. And then when you have competing standard setting bodies, it gets even worse. So I know in nano, it became a huge problem. We just had so many different standards. Companies were just sort of handcuffed. And as Laura said, it's a huge commitment to commit to a standard. You have to train all your staff and so on. So how do you decide which one to pick? You can't do them all.
exactly. Anybody else? So sort of to the same point, it seemed like the length of time it took to reach or take interoperability efforts varied across your cases. So Graham, you mentioned like about a century of time for the organics case. Gary, you mentioned that nanotech sort of started several decades ago, but didn't really start ramping up until the early 2000s, and Laura to the same effect. So we see the different consequences of this time frame to reach or take interoperability efforts. And I'm just sort of curious how you see AI interoperability efforts playing out. Like if they're taken rapidly, which they sort of seem to be going right now, if they're going at a normal pace or a slow pace, sort of like the organics took.
Well, I think, things like the OECD principles, UNESCO ethical guidelines, those were attempts, I think, by governments to immediately create some kind of globalized playing field. They're very vague and sort of general concepts, but they're important still. How they're actually implemented will be the key thing. But it's interesting. We saw this sort of almost immediately trying to create these international standards or at least guidelines from these large organizations. And then, of course, we have the G7 and G21 and so on, have been continuing to develop other guidelines in AI. So I think, right from the start, AI has been around for 70 years, but, since it became such a big deal, particularly with generative AI, there's been, I think, an attempt by existing international organizations to create some kind of level playing field. One of the big issues, I think, is China. China sort of initially was a major part of a lot of these discussions, and now they're sort of being isolated out. They're not part of OECD. The G7 is not including them. So there's sort of this interesting phenomena where we're the second largest power in AI probably is being, excluded from a lot of these discussions.
Anybody else? Graham, you just seem to be thinking about something. Yeah, go ahead.
Yeah, I think the thing I'd add here is my feeling is that I think this is where Laura's point is really important one around sort of the wide range or the heterogeneity of the thing that's at stake here. And so it feels as though there isn't going to be one particular trajectory, but there might be a multitude of different kinds of trajectories depending on the sort of the risks or benefits, right, that are at play from standardization or the efforts that standardization is trying to tackle, right? So I think the organics case is more on the front of the kinds of discussions within AI where people are thinking about ways to promote different forms of AI application that might be otherwise not prioritized because, for instance, they're not major markets. So smaller efforts to try to create a market for AI applications that that can get some premium, some benefit, some additional market value by meeting certain sets of standards that a subset of professional buyers, so companies that might want to position themselves as supporting particular kinds of pro-social AI initiatives or individual consumers or that they care about those sorts of things. So that's, I think, where the organics may shed some light on sort of how that will potentially remain a component of the discussions of this technology. I don't think that that's the center stage of what's going to happen, but it seems like it's an important component of what might occur, especially when we think about some of the smaller sort of assurance, AI assurance initiatives that are coming out, that are cropping up all over the place, that are not about interoperability per se, but they're more about wanting to provide like make visible a credence attribute of an AI system that otherwise there would be no credible way to do so in the marketplace. So I feel like that's where the organic story can kind of shed some light on what might happen with the AI marketplace of ethics, right, or environmental responsible AI developments. Um, what that how that will take form, it might be a really slow process like organics. It might take decades, right? I don't know if there's any specific organization. I mean, there's the space well, Benjamin, but there's the the group that set up the sort of AI auditing,
The
the
IEEE.
AI, yeah,
Yeah.
that organization.
International.
So maybe those kinds of organizations will remain important in providing an a separate set of discussions around what standards, how standards develop, because they are more about things that if will be invisible to the consumer of these products unless they're made visible by some credible mechanism. So but that seems like a very different standardization question than many of the others that we've been discussing around, like um, how the telecom or the internet protocols have been set up. I mean, there are some parallels, but I think they're quite different. And because in that case, like they aren't self-enforcing, right? So there's clear reasons why you want to be able to claim that you're ethical and not do any ethics, right? So you can sell your products that way. And unless there's some way to credibly demonstrate that through some enforcement mechanism, either by regulation or through some third-party auditing process, then that's not necessarily going to be trustworthy in the marketplace. So yeah, that might I just feel like that's going to be a storyline here, but it's maybe not going to be the central storyline of the way these standards develop going forward.
Can I just ask you, Graham, how critical do you think it was of USDA coming in and setting a standard in the United States for organic, as opposed to just letting it continue to sort of develop organically, bad pun, but by just private factors and so on? Would it have ever gotten to the point it is today in the United States, or was it critical for the government to step in? And then that might be a good question for AI. Does the government need to come in and set the standard?
Yeah, it's a good question. I mean, my sense is that some of my understanding of the US case, and each national case is slightly different around that. Like the EU has a separate story, but there was certainly a push from some of the certifiers at the time that it was an uneven playing field. So there were certain certifiers that were auditing to sort of different standards. So what organic was in California was different than organic in Washington State or in Delaware. And so they wanted some kind of harmonized national understanding of what organics would be so that everyone in the marketplace could trust that. My understanding is that it's also the Alar Apple scare was something that drove that kind of push, because at the time that was organic apples were the only apples that in the market that would have no alar on them. So there was a bit of a supply or a demand push from consumers that also was important to the sort of massive uptick in interest in organics. So in the context of AI, you could imagine that happening in the future. At the moment, it does not seem like that's going to happen, but it could happen in the future where there was a massive fragmentation in the marketplace, and there was a real struggle for consumers to determine what constituted ethical AI, however defined in the specific marketplace. So I think in some respects that's what people thought was going to happen pre the last election cycle, but that's certainly not where things are in AI at the moment. So, but it's a great question. I think that will be interesting to see what happens going forward.
Any other comments on question? Okay, I'm going to move into the Q&A. We have a couple questions, both from Craig Shank. So we'll ask those. So Craig asks, one topic that the conversation has gracefully not discussed is the current state of play in geopolitics at the impact of international institutions that are often drivers for interoperability in technical terms and regulation. He'd like to hear your thoughts on the impact of the geopolitical developments on likely paths forward for AI interoperability of both the technical and regulatory efforts.
Well, I think the key idea there is China, right? I mean, Russia too, to some extent, but China is a real technological force. And, how are they going to be included, if at all, in these international organizations and so on? I was involved in the OECD initiative on neural technologies, and they made a deliberate attempt to bring China in initially. In fact, we had one of our major meetings in Shanghai with a lot of government officials participating. But then 2 years later, I go to another OECD Neurotech meeting, and there's no way they're going to talk with China, and China's the bad guys, and they're on the other side now. And so a real change occurred in that couple of years of whether China's going to be part of the discussion or not. But they're not a formal member of OECD. There's a lot of debate and issues going on about China's participation in standard setting organizations. I don't know about ISO. But I know there's some parts of IEEE, it's very heavily dominated by Chinese participants. So they are participating in those type of enterprises where they get to help design the standards. And it'd be interesting to see where they're picking and participating, where they're not. I think they're part of ISO, but I don't know how actively they participate in that.
I guess I should answer this since I have a new book coming out called The Geopolitics at the Internet's Core, which is coming out this year. But geopolitics is infused in every aspect of AI, just like it is around the internet. It's not just about great power competition and the massive investments and the kinds of regulatory overlays that really are not geared towards protecting people, but protecting economies and protecting competition. That certainly is part of it. It's a big part of it. But also the use of artificial intelligence for foreign influence campaigns is something that almost can't be measured. It's even difficult to measure. It's so extensive. And also AI is already at war. If you look at AI intersections with weapons and with the use of surveillance technologies that are based on AI for national security. So the issue is entirely geopolitical. I appreciate the question very much.
Graham?
Yeah, the only thing I would add is it feels like some of the assumptions we've made about the trajectory we were on with sort of standards and the way in which standards, conformity assessment integrate into the global trade system, and the manner in which that was sort of taken as a starting point for a lot of the conversations about the role of standards in the development of AI going forward. I feel like some of those things are obviously may need to be questioned in a different way. So yeah, it feels like the context in which the development of AI governance going forward and the processes by which international standards might play a role, I think hinge a lot on how Gary has spoken and Laura about the role of China in those standard setting processes, and whether some of the politics and the geopolitics that are playing out outside of those standard setting processes kind of filter into them. If they suddenly become places that are not seen as consensus driven, then maybe at the moment you could imagine that they remain spaces where they aren't as political on the face of it, right? But maybe that will change. Maybe there'll be and maybe the roles of those organizations are going to shift. It feels like there's a lot that could change, but what that change will look like will be time will tell.
Any other thoughts on this question? Okay, so Craig has one other question and then I will wrap up. So Craig says the discussions have all touched on important motivations for interoperability, whether through developer collaboration or through regulation. What are you guys seeing as the likely drivers to help nudge AI interoperability forward? Is it the invisible hand of the market, the cooperation imperative of network systems, the regulatory imposition from the Leviathan, or something built into enlightened self-interest? As Gary and Graham sort of discussed, there would be more like Eleanor Ostrom's governance of the commons. What do you guys think?
Well, I could take a shot at it. It's more sort of maybe aspirational, but I would like to see supply chains become a powerful force. When I was in private practice, I represented a couple of big, large chemical companies, and they realized that their bottom line and even survival was based on not only their own practices, but that of their industrial company, industry customers. And so they created these very powerful product stewardship programs that they required their downstream customers to implement. And they'd send their own people into those companies to make sure those companies were following those product stewardship out of basically self-interest. Because if that company, that customer causes some pollution of a river or starts killing some people, they know that they, as a deep pocket, will be somehow implicated and sued. And so they quickly discovered it was in their own self-interest to make sure the users of their products use them as safely as they hoped they were producing them. So I'd like to see a similar type of ethic take over in the AI context of the large companies who are developing these models, having some kind of product stewardship that goes beyond just putting guardrails on the product itself, but actually following through with large industry customers and requiring some kind of, responsible AI governance system. Whether that's going to happen or not, I don't know, but I think that would be helpful if it does.
Cornelia, you raised, yeah.
Yeah, maybe just a little counter to what was just said, because I think what is more likely than this downstream towards customers is sort of the vendors to these larger entities, that they will fall into the frame that sourcing from vendors that also ethically structure their operations. On the customer side, I think market and economy plays a much more important role. And the AI space and the AI race is already happening there. So I am a little bit less optimistic when it comes to that ambition here.
Yeah, just a quick addition to that. I agree with everything that was said. I've talked a lot about technical drivers, so I'll just add ethical drivers. I think there could also be normative and social pressure around interoperability and the types of things that address concerns about explainable AI and accountability and auditability of decision making, especially when it intersects with very important social realms like healthcare or the justice system or the well-being of children. I think that we have to add ethical and social pressure to it. And then, of course, government procurement policies are always a big driver. But I did want to make a final point, since I'm a big advocate of interoperability. You still don't want a toaster connected to a nuclear reactor. So there are cases where you don't always want interoperability. And so all of the discussions that we've had here and the points that I've made are very, very context dependent.
Graham?
Yeah, I feel it's a great question. And the only thing that I would add here, it feels like I like Gary's point. The concern I have there to some extent is that that there's some lessons here we should think about in terms of the advantages that plays into for large incumbents, and the implications of that for the forms of AI that get prioritized. And I think that's where, say, for instance, the organic case and the participatory guarantee system that I mentioned is a useful one, because that was specifically set up with the idea that if you have highly expensive audit systems to be able to credibly make claims in a marketplace, that those are expensive for small operators. So that's why when you go to the local organic food market in Arizona, or in Washington, D.C., sometimes the local organic producers are not certified because they're so small scale, but they have other kinds of relationships with the buyers, that they build trust relations that are not on the basis of third-party independent audits that they can't afford. So in that case, I feel like it's important to keep in mind other ways in which this technology can be, that we design both public and private regulatory initiatives that give space for that kind of innovation, that provide space for pro-social use of this technology, that are not precluded from getting out into the marketplace on the basis of just the costs of governance, either that they have to develop internally themselves as a private sector entity, or that are imposed by governments. So that would be, that's sort of the question of like, who's going to pay the cost of these things, and what are the different ways in which trust can be generated around the development of sort of ethical AI going forward. Some that might be very institutional, like the supply chain stuff that Gary was talking about, or some that may rely on other trust mechanisms that we have to be aware of in the future. So another set of ideas to think about.
Any final thoughts before I wrap up? Okay. Well, thank you all for coming. And thank you to Graham, Laura, Gary, and Cornelia for your presentations and discussions. Google.org for supporting the project, and Gwen, Miriam, their CEIMIA colleagues for helping me organize and run all this. So please note that there will also be a subsequent webinar on this topic sometime around August, September as the project progresses. CEIMIA's social media pages will have information about this later on, and we will post a video of this discussion on our social media sometime in the next few weeks for you all to refer back to. Thank you again. Enjoy the rest of your day and week. Goodbye.
Bye.
Thanks, Benjamin.
Thank you.
Bye, everybody.